Hello, in this presentation I will discuss large language models and robotics. ChatGPT is a type of large language model. The agenda today is to first talk about traditional robotics, followed by reinforcement learning, how large language model works in robotics, why LLM in robotics, and possible extensions to power engineering. So traditionally, the robots were initially done on a line-by-line basis. Everything had to be exact. A robot does this, the consequences is this, and so on. One of the first, probably most innovative humanoid robots was Asimo, produced by Honda at around 2000. And it was predicted that in a few years, Asimo would be in homes, cleaning up the houses, at work, and so on. But this did not happen. Instead, it was retired in 2022 March. And why did it fail? First of all, it failed because it needed detailed and specific instructions, and therefore it had the inability to generalize, and every action had to be specifically pre-programmed. So this is where large language models and robotics comes in to save the day. So the previous slide, the robots were programmed on a line-by-line basis. Well, that has changed quite a bit. Right now we have this concept called reinforcement learning. And basically what it is that a robot is in a certain environment, he does certain actions, and these actions are either rewarded or penalized. The ultimate goal is to have the most rewards possible. Okay, these actions and awards, okay, these are all policies by the neural network, so it's all programmed into a neural network. For example, AlphaGo, which is a classic example of reinforcement learning, it was this application that played the game Go based on reinforcement learning, and it beat the expert Go player. So basically what AlphaGo did is that it played against itself, and it gave itself rewards when the actions were beneficiary, and penalized where the actions were not great. Whenever we talk about reinforcement learning, there's always the concept of exploit and explore. Exploit means that you take advantage of what you already know, and explore means that you explore new things. So these two in combination, figuring out a certain balance, will help the reinforcement learning to achieve its goal faster or slower, more accurate or not. So how does a large language model in robotics work? Basically, a person gives everyday language instruction. For example, can you bring me the drink from the table? And the robot will have an action go to the table. And let's say the robot has another question: do you want water or Coke? The person says Coke, and then the action is pick up the Coke. So essentially what's happening here is that the large language model provides the context for the robot. Okay, so it gives the question, can you do certain thing for me? The robot will say sure, but give me the instructions step by step. And then the large language model will give it step by step. And then for each step, the robot will have specific actions. Okay. So, and that's quite revolutionary, because before we didn't have this language processing ability. And also ChatGPT and LLMs, they're very, very popular for their ability to create instructions step by step. The classic example being, I am a high school student, I'm learning calculus. Can you give me a timetable to learn calculus for the next 6 months? So ChatGPT LLMs are very good at this, and robotics takes this skill and exploits it. So why LLMs in robotics? First of all, it's natural language instructions instead of like numbers and special keywords. It's all natural language. Generalized instructions. You don't have to say specifically, I want you to go here at this degree or that degree. You give a general instruction, and the robot is able to make it more specific. There's also the ability for zero-shot learning, whereby actions do not have to be learned before to be accomplished. For example, you can tell the robot pick up a banana, but the robot never knew what a banana is. And it also allows for greater combinations of actions. So possible extensions to power engineering. I see this as a series of steps. So for example, to restore from a blackout, what are the steps? To start generators for electricity needs, what are the steps? For planning for rolling blackouts, what are the steps? For scheduling EV, what are the steps? Thank you very much for listening. This is the conclusion of the natural language models in robotics. Thank you.